So we're back in our material handling program that we created in the last lab, and we're going to clean it up a little bit. Right now, if you were to approach this teach pendant in a manufacturing facility and look at this program, you'd probably have no idea what it does. And there are even some points in there that we could probably simplify or reuse. So one of the important things to remember, and this is with all robot programming, is it's really recording a point on where the robot is and defining how it moves. Once you record that point in this program, point 1 will always be point 1 in this program. So you can, anytime, if you were to go in and put point 1, it's going to go to that recorded data from the serial pulse encoders on each of the joints and where the robot actually was for point 1. So there's a really easy way to change that. So before I go any further, I'm going to show you at our cursor at the top, you can actually you can move across and get a lot more info on that specific point in that line. If I cursor over 1, you can see we can modify our motion to move in joint mode versus linear mode. If you remember, joint mode tends to be more efficient and faster because it's taking the shortest amount of time from point A to point B, and the robot does all of the math calculations to determine that efficient route. Linear mode is where we're following specific lines, and there's definitely a time and a place for both. And then of course we can have circular or circular arc movements as well. If we keep going, cursing to the right, we now get to where we actually have that recorded data, point 1. And you can actually go in and change this point 1 to a specific number, or you can also add in a comment or a label. And this will make it a lot easier to tell what our specific labels are at this point. But we're going to save that for now. We can also move forward and we can change, cursor to the right again, you can change our motion modify in terms of speed based off of percentage, which is typically used in joints, seconds, or meters per second. We can also go over and change it to a fine or continuous movement. Fine, as you can clearly see, it's where the robot's going to stop at that point. Continuous, it's going to start cutting corners. And if you notice when I hit continuous, I'm going to actually have a percentage scale here where you can see if you have 100%, it's going to cut the largest corner versus 5 or 10%, it's not going to cut that corner very much at all. But we're going to keep this to fine for now. What we want to do to start is we want to reduce the number of points that we have in our program. It's a little bit, there's too many added points, and we want to actually clean this up and make it a little bit more efficient. So before I go any further, I'm going to hit function, abort all. I'm going to hold down my dead man switch. I'm going to hold down shift, and I'm going to actually go and hit this step button again, because I want to actually remember where my points are, because right now I don't have any labels. Might be a little bit difficult to remember. So if we have it in step mode and use the forward button, make sure to hit reset. All right, so at this point I am at my home position and I like where that is, and I'm going to move forward now to my approach position. I also like that one. I like where it's at a good height. It hovers over the part, it's consistent. Now when I move forward, this is my work point. I'm going to actually pick up the part. And then when I go to my exit point, you'll notice it's actually a brand new point. It's 0.4 and 0.2, or sorry, 0.4. I want to make that to match 0.2. To me, that seems like the most efficient way, and then I don't have an excess amount of program points in my program. Now, the important thing to note is that when you can see there's a little @ symbol that is right next to the point, the @ symbol actually signifies where the robot is located currently. And if I were to go over and try to change this to 0.2, if I go over and try to change that number to 0.2, it's not going to let me do it. So one important thing to note is when you do want to change your actual points, then what we'll need to do is move the robot into a different position. Now I can go down and go to my next point, my exit point. I want it to make it 0.2. And then if I move forward back up to where my robot is located, and then sometimes you might see this error if the cursor's on a different line from where the program paused. In our case, it's okay because we have our gripper closed, we're ready to go. If I move forward, now my point is going to go to 0.2. So my entry point and my exit point, or my depart points, are exactly the same, which makes it a little bit more efficient in our material handling program. If we keep working through the process, I like where my interference or clearance point is, and then I'm going to do the same thing. Now watch my entry point versus where my fixture is being located. There is a little bit of an angle, and at this point that it's okay. We're going to adjust that, but if you look at my exit point, when I go from the robot, it goes straight up. So if you look, what's the more efficient one? It's probably going to be my exit point is far more efficient than what my entry point was. So what I'm going to do is I'm going to change my exit point, or sorry, my entry point, which will be right here, 0.6. I'm going to change that to 0.8. Now we're going to run through that again. You can see exactly where it went, which is nice. So this is my entry point. I go down, I unload the work, and I come right back up to that entry point. Makes it far more efficient. Now the last one to see is if we want to keep it consistent, and if we were running in a loop, my home position should probably be the same from start to finish. So we're going to do the exact same thing. Remember, you can't run it when the cursor or when the robot's there or located. So what I'm going to do is change this to 1. And then I'm going to go back to my position. So now my home points are exactly the same, and you will also see 2 asterisk marks to show that the robot is at that specific point. All right, so we still have the problem that if I were an operator and I was walking up to this robot program and looking at this teach pendant, I have no idea what this program actually does. So one of the things that we want to do is we're going to add a comment, or also known as a remark. And the way to do that, what we first need to do is we are going to go to Edit Command, and we are going to insert a couple new lines. This is good to know in case you need to add certain points. Maybe we need to have 2 clearance points instead of 1. But to edit a command, or to insert a comment, go to Edit Command, Insert, and it's going to ask you how many lines to insert. I'm going to do 2. We can always add more. Once you hit that, hit Enter. And then it gives me some space. You'll notice the lines stay the same just in terms of lines in the program, but the points stay exactly the same. That's the recorded data, and that's really important that we are consistent with the recorded data, and that's what we're referring to, and not just the lines of a program. From there, we're going to go to New Instruction, and I'm going to hit Miscellaneous, and there is a button or function here called Remark. And remark, you always can tell whether something's remarked because there's a little exclamation point at the beginning. At this point, I want to put in some text, And even just you can make a remark as long as it needs to be, but for our sake, we're going to do something simple like pick and place eraser, pick and place eraser over box. You can also put in additional comments and remarks that define what user frame that we need to use, what the DCS parameters are. There's a whole bunch of information that we can put into this, and we'll save that for a later date. But for now, I have a pretty good idea. I know what this program is actually going to do. With that said, it's still a little difficult to see which points are which. I can assume that my point 1 is my starting point, and because I see that there's 2 of them, it's a starting and the end. But in terms of approach points, interference point or clearance, and exit, we want to actually put in those labels. And that's really easy to do. If I scroll down to my first point here, and I scroll over, I can actually hover over the number. This is where we changed the specific number of point, but now we can actually go in and hit this comments function here, and I can actually change this to home. So now my point 1 has a label of home. If I were to keep moving down, and what I like to do when I'm going through this process, I still like to step through the program so I know exactly where I'm at. So make sure you hit function, abort all, just in case. Hold down the dead man switch and shift, and let's step through our program. So we're at home. We're now going to our approach points. So what we can change this to is very simply, we can change it to approach, just simply approach. You can also define approach 1 versus approach 2, but here we're just going to leave it at APPR for approach. I keep stepping through my program. Whether there's a part there or not is fine. We have our this next one. This is where the work is being done. So you can simply put in WORK for work. And then always remember to scroll back to the end, to the line, so we can move forward. Work is being done. Now, have you noticed, because point 2 is the same for our approach and for our exit points, the comment stays the same for each. Typically, that can be, it can be modified if needed, but if they're the exact same approach points, that's totally okay. I think we can even change the specific comments on that one, but for our purposes, this will be great. Scroll down to our next point. That's going to be the interference point or clearance, whichever works best for you. So I'll scroll over, and I'll just put clearance or clear. Then go to our next one. This is going to be that modified approach point. And with this one, again, it's going to modify this both 0.8s. But if we go in, we can change this to approach 2. So now we've clearly defined our different approach points. So I'm not going to move forward with the, I have an eraser right there, but you'll see when I move forward the program, all of those different points are labeled. Now the last thing that we might want to consider is in stepping through our program, we might notice that there's a couple of areas where we don't need to stop directly at the specific point and have that fine termination. So that's where, again, we can go over and we can look at modifying our motion from joint into linear. And we can also go and change it to continuous or fine. Now, typically, continuous motions are used for obstacle avoidance and efficient movement. Fine is used for actual picking and placing the part, where we need to be accurate with our robot gripper placement. So I'll change my, my home position. We'll change that to continuous, and you'll maybe make it continuous 50%. So it'll cut corners from 50%. And what you'll see here is that when we circle back to that point, it's going to move a little bit quicker than usual. For my approach points, I want to keep those with a fine position. So I have my approach, my work, anything that has to deal with picking up a specific exact part, we want to keep that very precise. But for something like an obstacle avoidance, like clear, if you remember, we're just clearing over the box, so we can actually turn this to continuous. Keep in mind though that if you do have too high of a percentage for continuous, you want to make sure that you are not actually going to hit your box because it's cutting the corner too much. So I typically leave it at continuous 50. And then what I'd like to do is actually test this out. So if we look at where our asterisk is at, that's where my robot currently is. I will hold down, hit reset, move forward. We're going to see our robot program step through, does the work, comes back. Now let's see our continuous point. And if we turn off our step mode, I can actually have it go, you can see it runs forward, backwards, or forwards. You'll see it kind of just very quickly and briefly stop. So that's the difference between having something work in continuous or fine termination, is what we call those.